Hello, this is going to be a video explaining how the robot works, like how it generally functions. And uh, during the Wednesday team meeting, you should have already heard about how the game works. So this will be kind of explaining how the robot is built in order to perform those tasks. So I think we'll jump right in. The first thing we're going to talk about is the base of the robot, otherwise known as the drivetrain. So just to give you a really quick overview, this here, what you're seeing on the screen, is essentially the entire robot. You know, there's a lot of colors and a lot of things happening, so it's a little bit jarring, but we're going to go through everything and make sure that you understand everything. Okay, so as I was saying, we are going to go from the base up. So let's start with the drivetrain. Okay, this is the drivetrain. So what the drivetrain is it's basically the base of the robot. If you think of it as a person, it would be like the feet, like the legs of the robot, mainly because this is what transports the robot. You know, this is where you have all your wheels, and that's what's moving the robot. So the first notable thing on the drivetrain are these little boxes. Thing that's being highlighted in green. These are called gearboxes, and gearboxes are not only specific to drivetrains. You can use them wherever you want, wherever you need to move things, where you have like motors and whatnot. But essentially, what it does is it has a number of gears that will change the output of the actual motor, so that it's not directly, the power from the motor isn't directly going to the wheel, and instead you're changing that to fit whatever needs and whatever requirements that you have. So you can change that by adding some gears. I'm not going to go too much into detail about how that works, but there are certainly many videos and explanations online that you could find and research on your own, or you could always ask any of the other designers on the team. I'm sure everyone would be happy to give you an answer for that. But here in specific, it depends on, every game, it depends how much we want to make our top speed and how much we want to accelerate, how quickly we want to accelerate. So that we changed the gear ratios in this gearbox to suit those needs. Okay, now you're asking probably okay, there are motors here, right? These things are, these cylindrical objects here are motors. Maybe I can get you a better view. Okay, there. These things are motors. They're probably asking, okay, so the motor's here, they're moving one wheel. What about all these other wheels? Okay, so that's a good question. Excuse me? Okay. The way that works is, since you have one wheel turning, or excuse me, let me get a good view so I can explain how this works. Okay, so if you can see right there, this axle is leading to the first wheel, this first driving wheel, and that is what's driving the robot, and it's essentially, right? But what isn't here in this CAD model are chains, and you'll be able to see them a little bit later on in this video, using a different part of the robot. But here on these little spiky, teethy little things, these are called sprockets. You'll have chains that go across, right? So that way, when this wheel moves, these other wheels move following suit. So that is how the drivetrain works. Yeah, so that is the drivetrain. Okay, then we're going to move on to intake. Going back to the robot, let's find intake. Oh, okay, this here is intake. Let's open that up and look at it. So if you remember in the when we talked about the game, we talked about how there are balls that we have to shoot into these goals, right? But I don't know if you noticed, but there were balls on the ground, and if you remember, there were ways to get balls from the user stations, and so the player stations, or whatever they're called. I can't remember at the moment. But in order to basically pick up these balls, we create an intake system. This intake system basically changes every year depending on what the game pieces are. Like, for example, a couple years ago there were like frisbees. Last year there were these like discs, I guess you could say. But this year we had balls. So we have here essentially this giant axle filled with, not filled, it has a lot of these special types of wheels. These wheels are called mechano wheels. And if this were a real life class, I would be able to show you how these wheels worked. But instead, we're going to insert a video of the prototype that when we were testing this out, that will hopefully give you a better idea on how these mechano wheels work in centering the ball and basically, sorry, excuse me, let me, okay, I'm back, all right. So essentially what these mechano wheels do is they kind of center the ball and then suck it in. That video should be able to kind of show you how that works a little bit clearer, since you can't really see here. But yeah, so the idea of the entire intake system is to suck up these balls and then transport them into storage. Okay, so that leads us to storage, which is another part of the robot. Storage actually has two parts. There is the actual structure that like holds the robot together. It's kind of like the body. If you remember how I said drivetrain was the legs of the robot, intake would be an arm, and storage would be the body. So there are two parts to storage. There's one, the actual structure. The second part is the storage, the ball storage. So the structure, we can talk about that very briefly. It doesn't have much of a function other than to just be a support structure to hold other subsystems and whatnot. There's nothing too exciting here. It's just support structures. Although it is exciting, I didn't mean that it's not exciting. It's not a focus that I want to focus on right now. Okay. Now the second part of storage is the carousel. If I can just get that open for you. Okay, here we are. So the carousel. As the game requires, you can only have 5 balls on your robot at one time. So what we decided to do this year, or last year, was to create this carousel that would hold these 5 balls. And if you remember, when we talked about the intake would suck up a ball, and then it would transport it into actually this. It would transport it straight into here. So what this is, if you see, sorry, I'm going to turn off this highlighted thing. But essentially, if this were the ball, you can, I don't know if you can see my mouse, but hopefully you can. It would essentially it would fall into, not fall, it would get sucked up from the intake and land here into one of these compartments. So there are 5 compartments. And what these compartments do is they hold the ball in such a way that it won't fall out. And the way we do that is how we have brushes. So these brushes keep the ball in, but you can't really, the ball won't fall out. You can stick your hand in and yank the ball out if you wanted, but I mean, nobody's going to do that during the game. So this was our ideal design. That was how we designed this, so that you could suck in a ball and have it rest in this little compartment, and it would stay there and it wouldn't fall out until you needed to basically transport it to the shooter. Okay, so speaking of shooter, we can go and look at that now. Now, shooter is a very, very interesting subsystem. Oh, that's not what I wanted. Okay, so the shooter is a very interesting subsystem. So if we go back to the analogy of the robot being kind of like a human body, where drivetrain was the legs, storage was the body, and intake was one of the arms, this would be the second arm. I'm going to use an analogy of a basketball player. So imagine that you're dribbling a ball, right, and you want to shoot. There are many ways there are many ways that you could decide to shoot. You could turn your entire body into face the hoop and then shoot, or you could turn your hand and not your body and shoot. Both have benefits and disadvantages, but the second version will save you a little bit of extra time. So in order for our robot to do that, we needed to make this shooting mechanism rotate. And that is why we employed a turret. Hopefully I can open up that assembly for you so you can see it. Okay. Oh, it's right there. Bye-bye. Okay, so this here is the turret. Now, if this doesn't really make a lot of sense, I don't blame you at the moment, but we will also insert a quick clip of a different team and showing off their turret. But if you can see here, this is a motor. If you remember what the motor on the drivetrain looks like, it's very similar. You have a motor here, except it's going upwards. And you have here chains. Remember how we talked about in the drivetrain we had chains? You have chains here too. So these chains would move this circle right here and move it so it could turn. Then your shooting mechanism would sit on top of here so that it could shoot. Yeah, okay, we can take a look at another team on how they did their, just to help you visualize. Team 2363, I'm using their video. I'll skip to the part where they actually show it in motion. So you can see, right, here you have your motor and it's moving while, if you remember when we were talking about the drivetrain, we talked about a sprocket, that spiky thing. This is the exact same thing, just a different size. And you have your chain, right? And so as this motor is moving, this chain is also moving, and thus it is moving this entire plate. And that is how you would achieve that that movement of, like, if we go back to that example of a basketball player, you achieve that movement of moving your hand versus moving your entire body, right? So that is how that would work. Now there's a second part to the actual shooter, which is the actual shooting component, if that will open up here. But essentially how that works is, well, I'm gonna let that load up very quickly. Oh no. Oh no. Okay, I guess, oh, okay, I don't know what that was. I don't know what happened. All right, but we can see it now. Let's take this view. So what the shooter does is it takes the balls from storage. So remember the carousel we were talking about? It takes the balls from there and it shoots them into those goals that we talked about on Wednesday's meeting, if you remember from the game explanation. And what it wants to do is it wants to shoot as many balls as quickly as possible from different firing locations. So that's why we talked about the turret. That's why it can move. It can, like, rotate. And this here would be kind of how it's, I'm gonna turn this off. So these two wheels here are kind of what shoots the ball, right? So your ball will enter in from here. So if you have your carousel down here, your ball will enter from here. And because of the pressure put on by these wheels and the hood right here, it will shoot the ball out. And this hood here is actually adjustable, which is a very cool feature that our designer made for that. And what that does is it can change the trajectory of the ball. I actually found another video from another team that did a very nice, and they had like a prototype here from team 624. You can watch their video too and see how that works. So you see that their ball is going through, and this these wheels here are moving in such a way, are moving so it shoots out those balls. Yeah, and then if you saw right here, the hood moves. So if you were to shoot a ball out right now, it would follow a different trajectory than it would if it were down here, the hood. Okay, so that is the shooter. The next subsystem that we will talk about is climber. Okay, climber. Let's open that up. Ooh, that's interesting view. So climber is, if you remember during our Wednesday meeting, we talked about how in endgame there is the last 30 seconds of the game. One of the challenges of the game is for the robot to climb onto this like triangular hanging thing. It's called the generator switch, and this here is how we were going to climb onto that generator switch. And the way that works, maybe I can wonder if, yes, I can. Yes, cool. The way that works is we had these, we use these extended arms. These arms would extend and then essentially, whoopsie doopsie. Oh no. I'm clearly very, very good at maneuvering this. But the idea is that this would, oh man, the idea was that this would basically shoot straight up and grab onto that generator switch, right? Yikes. Anyways, yes, the idea was, there we go. Okay, that's okay, well, whatever, we'll deal with this. The idea is that this would lift and grab onto that generator switch and then basically go back down, and thus it would lift the robot up. There are probably some teams that have something very similar to this. I wasn't able to find a video that showed their climb, but if I find one after I finish recording this, I will put it in the description box of this video. Okay, and then the last subsystem is the control panel spinner. If I can find that. Oh, here we are. Okay. All right, so the control panel spinner. If you remember in the game, there was that like rainbow wheel that spun. That was the control panel. At the moment, I can't really remember exactly what the requirements for like what to do for that was, but in this essence, all you had to do was spin the wheel a number of times or to a specific color. And this is how we did that. We had this essentially this arm that went up, and this compliant wheel, which is basically a rubber wheel, so it's kind of squishy, and it would basically jut up against sorry, excuse me. It would jut up against the control panel, and it would spin. And because it was rubber, it was able to, and because it was rubber and it was like adding a little bit of pressure on there. Like if you think of like putting your hand against, I don't know, a cake thinner or something, it would be the same kind of idea. Like you have, because your hand has texture and has friction, so you were able to move it that way. Yeah, so this wheel here would move, and then at the same time it would move the control panel spinner. Yeah, so that is all of the components or subsystems on our robot. our 2020 robot. Yeah, so I think we're going to insert a quick demo of some of our robot, courtesy of Sid, and be sure if you can try to point out which parts which like subsystems you see are more moving, and maybe you can tell like, oh, this is this subsystem and this is how that works, and hopefully that'll make a little more sense. So I hope that you enjoyed this video. For some of you it was homework, for some of you it was out of pure curiosity, so I'm very glad that you got to the end of this video. So thank you for listening, and yeah, that's about it.